Simon & Schuster Audio presents Einstein, His Life and Universe by Walter Isaacson. Read by Edward Herman.
The Light Beam Rider. "I promise you 4 papers," the young patent examiner wrote his friend. The letter would turn out to bear some of the most significant tidings in the history of science, but its momentous nature was masked by an impish tone that was typical of its author. He had, after all, just addressed his friend as "you frozen whale," and apologized for writing a letter that was inconsequential babble. Only when he got around to describing the papers, which he had produced during his spare time, did he give some indication that he sensed their significance. "The first deals with radiation and the energy properties of light, and is very revolutionary," he explained. Yes, it was indeed revolutionary. It argued that light could be regarded not just as a wave, but also as a stream of tiny particles called quanta. The implications that would eventually arise from this theory, a cosmos without strict causality or certainty, would spook him for the rest of his life. The second paper is a determination of the true sizes of atoms. Even though the very existence of atoms was still in dispute, this was the most straightforward of the papers, which is why he chose it as the safest bet for his latest attempt at a doctoral thesis. He was in the process of revolutionizing physics, but he had been repeatedly thwarted in his efforts to win an academic job or even get a doctoral degree, which he hoped might get him promoted from a third to a second-class examiner at the patent office. The third paper explained the jittery motion of microscopic particles in liquid by using a statistical analysis of random collisions. In the process, it established that atoms and molecules actually exist. The fourth paper is only a rough draft at this point and is an electrodynamics of moving bodies which employs a modification of the theory of space and time. Well, that was certainly more than inconsequential babble. Based purely on thought experiments, performed in his head rather than in a lab, he had decided to discard Newton's concepts of absolute space and time. It would become known as the special theory of relativity. What he did not tell his friend, because it had not yet occurred to him, was that he would produce a 5th paper that year, a short addendum to the 4th, which posited a relationship between energy and mass. Out of it would arise the best-known equation in all of physics, E equals mc². Looking back at a century that will be remembered for its willingness to break classical bonds, and looking ahead to an era that seeks to nurture the creativity needed for scientific innovation, one person stands out as a paramount icon of our age: the kindly refugee from oppression, whose wild halo of hair, twinkling eyes, engaging humanity, and extraordinary brilliance made his face a symbol and his name a synonym for genius. Albert Einstein was a locksmith, blessed with imagination and guided by a faith in the harmony of nature's handiwork. His fascinating story, a testament to the connection between creativity and freedom, reflects the triumphs and tumults of the modern era. Einstein's life and work reflected the disruption of societal certainties and moral absolutes in the modernist atmosphere of the early 20th century. Imaginative nonconformity was in the air. Picasso, Joyce, Freud, Stravinsky, Schoenberg, and others were breaking conventional bonds. Charging this atmosphere was a conception of the universe in which space and time and the properties of particles seemed based on the vagaries of observations. Einstein, however, was not truly a relativist, even though that is how he was interpreted by many, including some whose disdain was tinged by anti-Semitism. Beneath all of his theories, including relativity, was a quest for invariance, certainties, and absolutes. There was a harmonious reality underlying the laws of the universe, Einstein felt, and the goal of science was to discover it.